Okay, this should be it. Yeah.
Everything must change. Everything must change. No one stays the same. Nothing and no one goes unchanged.
What I feel when I make music is like energy.
Gave you my love. Still you took yours away. Why did you take away your love? Oh, when mine was here to stay. Oh,
You know what? Fuck it, I'll play my damn self.
gave you my love. Still you took yours away. Why did you take away your love? Oh, when mine was here to stay. Oh.
Language liquid, get lifted, love life and live it. We twisted, been shaped and shifted. We gifted, young black with lyrics. We thrive to keep the party live. We strive to be wise and enterprise. Socialize, dip and never die. Set the vibe and keep our eyes on the prize, y'all.
Stay on top of this, see if you can follow this. Drink and swallow this, heat from the hollow tips. Bounce, rock, skate with the quickness. Shake your hip to this, tell me if you're feeling this. If you are, let me know who you are. Turn it up real loud, let it be in your car. I'm the best by far, like my man Omar. Make a real loud noise, let me hear where you are. Yo.
You act slick in this rap shit, get slapped quick. Match wits, words seal up the cracks like chapstick.
Rappers, I'm bound to slay. I'm saying hi to all the cuties from around the way. Yeah. Yo, it's a must that I get papers. Peace to all the DJs who gave me love on they mixtapes. And once again, the man's back with a dance track. So here's your chance, Jack, to get loose and let your hands clap, clap. quick money grip, blow your asses out. In a street brawl, I strike men quicker than lightning. You seen what happened in my last fight, friend? I then. L's a clever threat, a lyricist who never sweat. Comparing yourself to me is like a bench to a Chevrolet. And clown rappers, I'm bound to slay. I'm saying hi to all the beauties from around the way. Yeah.
Hey guys, I'm about to get started in a bit. I'm trying to work through this chat. I don't know why it's disabled right now. So I'm trying to get it disabled. Or sorry, I'm trying to get it enabled, and then we'll get started in a second. But for now, just we'll be vibing out to some music.
Yeah, 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 yeah.
Kids.
Ladies and gentlemen, get ready, here come Talib Kweli, and I'm banging on your eardrum. What? Now let me get a minute. Wait, friends, Romans, countrymen, lend me your ears. Don't repent it cause the end it is near. But don't panic, you can't function if you live in fear. Pay attention, you gotta listen to hear. Who the fuck you think you're talking to? Put you on hold, get a specialist to walk you through. Kweli, the flow captain, the fast, the slow rapping, I'm so cracking. You ain't heard, you should have been like closed captions. King of the bars, and I'm going hard pause. All my confidence comes from knowing God's laws. Banging on the system, fighting my kind of war. Loud as a whisper, quiet as a lion's roar. Ladies and gentlemen, get ready, here come Talib Kweli, and I'm banging on your eardrum. Now let me get up in it. It's for your spirit, so y'all hear me though. Get up, get into it, and get involved. There's a little something that I wanna spit for y'all. Now let me get up in it. Wait. Get it now, get it fast, get it right, get it big, get it live, get it done, get it tight. But you don't really hear me though. I spit it clearly so it's live out your stereo. To your heart while it's beating in your chest. As you're speaking to execs in the seat behind the desk. To your spirit, nothing wicked in the flesh. So while you try to keep it fresh, you're getting deeper into debt. Real hip hop is missing from the shelf. Yup, it's what you felt when you listen to yourself. Only a few is making cuts that's finished. So before you spend your hard-earned spinach. Ladies and gentlemen, get ready, here come Talib Kweli, and I'm banging on your eardrum. Now let me get up in it. It's for your spirit, so y'all hear me though. Get up, get into it, and get involved. There's a little something that I wanna spit for y'all. Now let me get up in it. Wait. Yeah, rudder sounds coming out your speaker. I spit rounds like
okay.
a 9mm. The youth today, they frown at the teachers. They ain't down with no leaders. They don't wanna wait just a minute. They like, what, nigga? Wait, right there. I got reservoir dogs. You be missing the right ear. Get it clear. I figure it's my year. I'm everywhere making appearances and niggas nightmares. Hear the words, peep the flow, check the cadence. What you heard is a pro. I'm so amazing. Don't front, girl. You know it's your favorite. New Kweli, yo. They running out of patience. Ladies and gentlemen, get ready, here come Talib Kweli, and I'm banging on your eardrum. Now let me get up in it.
All right, I think all my audio is good. My screen audio can come through, my voice can come through. So I'm gonna go ahead and get started and get this. All right. So just continuing from my last study session, I went through Ethernaut Hardhat level 0 or first level and the second level, or level 00 and level 01. I think that's the fallback solution, the fallback problem. And so what we did was we did it with an externally owned account. So let me just get back into the code. Can't remember where we left off. Okay. Yeah, so yesterday we did it with an externally owned account. So basically simulating this attack from a wallet. But today I want to study doing this with an attack contract. Because as we get deeper into these, I believe we're going to have to start having to use contracts instead of just being able to send, raw transactions um, to the attack contract or to the contract we want to attack. So let me pull up Ethernaut really quick. What do I have on this screen? Okay, yeah, we'll just leave off from where we start off from where we left off. So completed this challenge, but I'm gonna basically just get a new instance so that we can restart this challenge. So let's get a new instance. Sign this up. Okay. All right, we're good to go. All right, now I can stop managing. I'm basically trying to look and make sure everything is working, but I think we're good. So now I'm going to stop playing with that and jump into this. Okay, so what we want to do is... All right, so for anyone jumping straight into this challenge instead of watching the last stream, to do this attack, this is the code. So this is the code for the contract that we're trying to break. And we have a few things to accomplish. First, we have to claim ownership of the contract. So we need to be the authority of this contract. And then also we have to reduce this balance to 0. And essentially what's happening here is whoever initializes this contract is the owner. And they're essentially like the contributor who has paid the most. And they're also the owner of this contract. So they can call the withdrawal function and all this good stuff. But when we first start off, we are not the owners of this contract, and we cannot modify any of the data inside of it unless we contribute some money. So I'm not going to do a deep dive of this contract because we did it in the last stream, but I'm going to just kind of kick it off and work from the attacker's point of view. So let's go ahead and for anyone who's watching on these, if you're joining in the future, you could stop in, study something else while I study, or you can help me with the solution, whatever you want it to be. This is just a space for us to study together, and yeah, have fun. All right. So let me grab this. What's the contract address? All right, so the instance address is this contract address. Okay, let's grab this. And actually, I'm going to create a whole new test for this. There you go. Let's go ahead and copy this template. New. This test, they're gonna still be the same. Actually, let me keep the tag flow. Okay. Okay. Call that contract attacker. We're gonna want that to be a contract. Okay, so let's go ahead and create a new contract called so I'm gonna go ahead and copy this up. Okay, import this. And let's make so I need to first inherit all this stuff, bringing all this stuff correctly. So So basically, what I'm doing right now is figuring out how to call another contract. So first, I have to pull in that contract information, and then I have to use that contract's ABI to call the correct function that I want to trigger. So right now, that's what we're working through. And I could do it this way, but I want to do it to where I can just pass in. Whenever I go to deploy this contract, I want to be able to pass in the particular contract because it could basically change. That's the best way. So, no, I don't want to do it with Hardhat. Let's go to docs. Maybe I should just look up cross contract. Uh, no. Flag. Address. That's the colleague. Then we have this address. Does it need to be payable? Hmm. No, I just initialize that. Pull up that contract. What addresses? Which is payable fallback function? Okay. All right, so now I think we can initialize this attack contract. Okay. Yes, okay. So now we can do function attack. Um, and if anyone is watching this and they're like, what did I just do to fix this? So this contract, this initial fallback contract is payable because it has a payable receive function or payable fallback function. So whenever I went to basically what I'm doing is I'm importing this contract and I want to be able to make calls to this contract via another contract that I'm creating, which is going to be my attack contract. And I was running into issues because I forgot that I needed to make this address payable. So yeah, basically, you kind of watch the process of debugging. Building contracts is not always that easy. You may forget a small step or have to do some research to figure out how to basically construct this attack contract. So now what we're about to do is I'm going to make a attack function so that first we're going to do a few things. We're going to contribute to this contract, and then we're going to send some data send so a value to this contract without any data so that we can invoke this fallback function. So I don't know how to build this. I'm just going to kind of go with it and see what we can do. So this should be payable. Tag. Is this a? Let's look. Yeah, I think this should be payable. And the first thing we're going to need to do is contribute. to fallback contract. Then we're going to need to send value back. This allows me to become the owner. And then what we're going to do next is we're going to have to call the withdraw function. Okay. Yeah. It should work. And actually, I want to call the withdraw function for myself. I'm going to make this. So another thing is, some attackers, and obviously this is for educational purposes, some attackers may pull off an exploit, but forget to create functions for so that they themselves can actually withdraw the money they have taken. So, for instance, this contract is going to commit an attack, and it's going to steal some funds from someone else. If you don't program in the ability to withdraw or to claim the stuff you just stole, then you essentially just locked. You kind of just made an attack for no reason. Um, so this is something that's interesting because I think an article came out recently where they were able to like rehack the hackers, and I can't remember if they forgot to withdraw the funds correctly, but this is just like something we should do when doing these CTFs and kind of learning is, okay, we've made the attack, now how do we actually withdraw the funds after we make the attack? So let's say public, and I could put modifiers and stuff on this, but I mean, we don't really need to because we are going to take all of this. So let's say, what do I do? Message.sender. No. I can't remember how to get the balance of the contract, but it's like balance of this or something like that. We'll figure it out. But that's essentially what we want to do. So withdraw money. Withdraw the stolen money. All right. So let's just leave this blank for now, and let's figure out this first part. And I don't need this. Okay, so first we want to get this fallback contract, and we want to call the contribute function. And we're going to contribute the value that's sent to this attack function. One argument is given, but 0 expected. Oh, I think I'm supposed to do this. Expected. I don't know how that's expected. Let's see. Oh, okay. So value. Change that. Let's get all the way up. Okay, now what we got? Wrong argument. Wrong argument function. Wrong argument given but expected 0. Hmm. So I just passed the value. I don't think I gave an argument, but oh, there we go. So yeah, basically what I'm doing is the person that's sending the ETH, we're gonna send it to this attack function first, and then that attack function is gonna call this contract and contribute some of that money. So, and then after this, we're going to send value to invoke fallback function. So we want to replicate this right here. When we were doing this with Hardhat and Web3.js, we were basically simulating this from the wallet. But what we want to do is it's this right here. We basically want to send a raw transaction that has some money and no data. Okay. This. So this is how I believe we send. Yeah. It's to address. In contract fallback user address. Fallback contract to access this address. Remember. Okay, so I have to do this. And we're not going to use that one. All right, so I believe this sends the value, but first what we need to do is okay. But over here stuck in JavaScript mode. Oh, yeah. Basically, all I'm doing is just cutting the value sent in half so that because essentially we have to send multiple values. So we're sending a value 1 to this contribute contract to register me as a contributor, and then have to send money to the fallback function to be able to change the owner. And we're going to check to make sure that was sent, and then let's call the withdraw function. Fallback contract, withdraw. All right, I think I just saw something related to the balance. So let's grab the where did I see it? Let's grab the balance of this contract, because what we want to do is after we withdraw everything, we won't know how much is in it. So we're gonna withdraw everything, and then when I go to call withdrawal to claim my stolen funds, I'm going to just withdraw the balance of this contract. I just saw there's like a better way to do it. As Ethereum changes, there's better ways and newer ways to do some stuff. So uh, I'm a little bit older, but okay. All right, address this. That balance seems it still seems to be in style. So No. No argument. Oh, I got mixed up with my own withdrawal function. I can do it this way. Is it? All right, let's figure out how to transfer this. I mean, I already made the address payable. I guess that's some new changes. I don't know. Hmm. All right, so we have the owner. I just want to make the send money back to the owner of this. Okay. All right, that should pull up the hack. Let me. Yeah, let's just give it a shot and see what happens. If anybody is on stream, then feel free to say if you think it's not gonna work, missing something. Yeah, anything that should be added to this contract. I can't tell if someone's in the lobby, but we'll continue. Tag. Let's go to this. Okay. So another thing is I don't do this, but I need to learn how to deploy um, my own contract. So let's do two things first. Let's make sure this stuff compiles. All right. We compile good. Let's part. It's good. Yeah, no, this is this what this is for because I think I did this a while back ago. Um, at the same time and coming back into it, it's like snap. But that's why I like doing this because it helps refresh some things that I've completely forgot how to do. Like I forgot how to deploy, and so I'm relearning these things. And now that I'm doing it through here, I can remember. Cool. Thank you. Thank you. All right. So I think the next step is I need to deploy my own attacker contract. Let's see, deploy my own attacker contract. Let me just do the pseudocode for this because I have forgot. So we have attacker address is going to be equal to wait ethers deploy contract. Yeah, and let's throw in this attack. Oh, another thing is I messed up on naming convention. So I'm actually I don't even know, but I'm pretty sure these need to be all caps. I think a part of learning cybersecurity and getting good with like smart contract hacking is to really practice. Basically try to practice what developers should be practicing. Because if we're going to be, telling developers where they're making mistakes, we have to make sure that whenever we're learning how to build, we try to do best practices at the same time. So, um, obviously, if it's an attack contract, it doesn't have to be polished up because the objective is to really steal all the funds. But for the most part, like some things like this, then try to mimic what a developer would do. And also, it would just help whenever we're going to actually simulate an attack, draft up a POC. Um, these are just things we have to practice. So, all right. So going back to here, I have to deploy this contract. I believe this is um, the right way, but we'll see. So deploy contract. Next, we have to grab something. Just grab the attacker as the signer. Yeah, because I'm the attacker. This is basically going to get my private key. Um, Anyone who's watching this in the future, basically, I have my private keys and RPC URL link um, embedded into this .env file. And so, if you're wondering, like, okay, how the heck is he even getting a signer? That's where it's grabbing that data from. So I'm going to be deploying this contract with my private keys, and we'll see what happens. All right. Contract factory. If your contract requires constructor arcs, you can specify them here. So I need to create a factory first. And then I can deploy. Contract factory. Here we go. How old is this? It's 2 years old. Maybe there's a newer way. Like 2023 Hardhat. Next, I'm just gonna go straight to the docs because provider wallet. I guess I still have to do it this way. I could have sworn I've done this without having to pull all this down. Yeah, no, this still looks outdated. Hold on. There you go. Yeah, yeah. So you don't have to pull down the API anymore. That was a little bit outdated. So um, I think I do remember having to do that. So yeah, we have to get factory. So const attacker contract factory. So wait. Oops. Ethers dot get factory at get contract factory, and then we pass in this, and I think it's doing what those posts on what those posts were talking about. This is a cleaner way to do it, but it's just going to grab some of the ABI data, some of the information about your contract so that you can actually deploy it. And then we go to here, const attacker contract. I think that's the right way. Yeah. Deploy. So two things. So we have this contract address. This is going to be a argument for our constructor. And that's why I didn't, I mean, I could have hard coded it in here, but typically you want to, oops, wrong one. Typically you want to leave this as like a variable so that you can pass in whatever contract you're trying to attack. So let's come back here. So we have our contract address, we have attacker, contract address, and then we pass in and I don't need to deploy this with any value. So yeah. Wait, ethers. Oh, it's not ethers dot. Okay, so messed up. Attacker contract factory dot deploy. And then we're gonna, okay, there we go. We pass in the argument. So the only argument we have right now is this contract address, because we're passing it in here. And then yeah, let's go from there. And what I want to do is just see if this deployment works, because Ah, didn't know about this one. So I guess Hardhat upped their game. I did this a while back ago when I got into Solana security. I was playing around with this, but I forgot. So it looks like there's a lot of updates that I have not didn't even know of. Um, all right, and then let's just have an amount. There's a few things I want to do. We need a global variable so that we can call a few of these things in our test. So in JavaScript, you have scope. So basically, if we initialize a variable inside of this test here, we're not going to be able to check it and run it, or get that information from that variable in another test. So what I'm doing is I'm going to set a few variables. We're just going to initialize them. So one, I want the attacker. I want to be able to use that address. I want to be able to use the attacker contract. What else do I want to use? Maybe the fallback contract. I think we'll want to use that as well. And one thing to make sure is you don't shadow your variables. So we're going to remove this. Attacker, we have that. Attacker contract, fallback contract. That should be highlighted. I don't know why that's not highlighted, but okay. All right, so what I want to do is let's just look at this fallback contract. I want to know if I can get this transaction, but let's just see. And I'm probably about to burn a lot of my testnet ETH doing this, but it is what it is. Maybe I should just go ahead and just try. Hmm. I'm contemplating whether I should just go ahead and try the attack as a whole instead of just checking if this deploy. Because I really don't want to waste more gas and more of my Sepolia ETH than I need to, but it's whatever. All right, let's give it a shot. And we want to test a new file, so it's going to be our contract attack fallback, and then remember we have to do the network, and we're on Sepolia. Oops. If that's the right name. OLI, yeah. All right, let's give this a shot. We're probably going to run into some errors, but that's the point. Invalid artifact path contracts. Wait, that should be from compiling and not from running the test. Yeah, okay. So this is not an issue right now, at least with this. This is with this attack contract. So I think I didn't do this correctly. Invalid artifact path contract. Hmm. Oh, I think it's because when I changed the name. Okay. Well, I don't know why I can't just change it to a new one. No. Tag.soul. Is some loud thunder. All right, so we're into an issue. Don't really know what the issue is, but we're gonna take a look. Its correct case in the path is. What is this all about? Okay, so this seems like a hard hat thing. I wonder if Foundry does stuff like this, but we'll learn after this. This is kind of whack. Right, clean. Wow. Okay. So it looks like whenever you compile a contract with specific names, if you change it, your artifacts are going to look a little different. So Hardhat was basically just giving me a tough time and saying, you need to make sure you clean out those artifacts with this command, and then we can recompile. So now let's try to do our original test right here. Okay. So where do we get an issue? Console is not a function. Yes, because I need to log it. New owner is not defined. That's correct. I have not defined the new owner yet. I should probably just take this out for now. All right, so basically what we're trying to do is make sure that we're deploying this contract correctly. My laptop's about to die. Hold on. All right, so I want to, and honestly, let's see if it deployed. Because if we check MetaMask, we could potentially see if this deployed or not. Let me get rid of some of this crap. All right. So this is Sequoia. Yep. Search my address. All right. So it actually did deploy. The issue that I had was just um, I didn't log this correctly, but our script works, so that's a good thing. And let me just take a look. So another thing within Web3 security is, and this is something I have to learn more with Ethereum, but in Solana, like we have to make sure whenever you're deploying stuff, you're taking a look on whatever, I think on Solana it's called SolScan, but here we have EtherScan. So learning how to kind of take a look at a transaction, see what it's doing. Because for instance, if a hack occurs, you can take a look at all that data. It's all on chain. So let's take a look. We have created contract creation. Okay. From my account, this is the new contract. Let's see if we have no token transfers. Now, I could have done created a script where we can like automatically verify and publish. But let's see if this can do it. No similar contracts. Let's see. Ah, that's not that important. Okay. So we're deploying our attack contract correctly. We're getting somewhere. Now what we want to do is, as an attacker, I'm gonna send a transaction from my MetaMask wallet to this attack contract to go ahead and initiate the attack. So remember, it's going to contribute, it's going to contribute some amount. Then it's going to send some amount to the fallback function, and then this contract should now be the new owner, and then I can withdraw all of that money. So let's come back to here. And so before, when we were doing the attack locally on our in our Hardhat script, we had to like perform all of these steps, right? Contribute, receive, withdraw. These are things we had to do. But now this is like a more sophisticated attack, because all the attacker has to do is go, oops. Why are you not highlighted, sir? Okay, that's weird, but so what we do is attacker dot no. What we do is let attack transaction. So what we're going to do is grab this attacker contract, right? And then we're going to call the attack function. That's going to kick off everything. And remember, we have to also send a message.value. Now, I have to cheat on this and look at how we parsed Ether again. So this is the right way to do it. All right, so we're going to send some value. And what this is going to do is just divide this by 2, contribute, and then call the callback function. So let's see if this works. Another thing I just learned recently from Patrick C. Alpha's videos is making sure you grab that receipt. So let receipt, or I'll say attack receipt. And sorry for my spelling, I can't spell receipt, obviously. Attack receipt is equal to ethers, or await ethers dot await transaction attack dot wait. I think that's the right way to do it. So what this is doing is waiting for this transaction to complete. Some people may do like a time delay, but I guess like a better way to do that is, instead of specifying like I want to wait 3 seconds or 5 seconds, you don't know how the blockchain is going to be operating at that point in time. So if a lot of people are using chain and you're trying to, and obviously this is educational purposes, if you're trying to commit an exploit, you wouldn't want this to be like wait 3 seconds, because now you've done all the work of setting up your attack and everything, and it's going to fail because it hasn't waited for your transaction to complete. So if you're performing an attack or drafting up a POC and you're like, okay, this is not working, try to maybe use the wait function, because it's basically just going to wait for this transaction to complete. So um, what should you contribute to? Okay, so we don't need to worry about this flow because it's actually all happening in one fell swoop. Now, what I will need to do is call the withdrawal function. That's just if I want my ETH back. So let's just perform this attack first and let's see what happens. We may run into some issues, but that's okay. All right, the moment of truth. Ooh. Okay. It's like, how's that not a function? So we did not await. This is an asynchronous call, so we need to make sure we wait for this to complete. All right. Let's try this again. And I'm terrible. I should have console logged this, but okay, that's the first one. I don't need that. This is our contract that we just deployed. All right, what happened here? Call exception. All right, here's where the fun begins. This is the non-glamorous part that happens a lot with coding, hacking. It's really like primarily your day is debugging stuff and running into errors, and then the 5 minutes of it is actually like the attack working. Um, so here we go. So we have an error call exception. So something failed with that call. I think I like to go and look at that transaction. So let's take a step back and look at nope. Let's take a step back, look at what I called, and we're gonna see this attack. We're gonna see this fail like in real time on chain. I personally like this way better. Sometimes error messages will give you what you need, but being able to jump on chain and look at a transaction and kind of dissect it and see what went wrong is a great way to understand what's happening. Also, it's a great way to understand what's happening when someone actually performs an attack and you're like, you can kind of look on chain and investigate. So, okay, error encounter doing contract execution. This value was sent. That was a transaction fee. Okay, let's go and see why this failed. Okay, it knows this is the value I was trying to send. It correctly registered the method I was trying to call. Internal transactions. All right, so why did this also If you remember, I divided it by 2. So this is call 1. This is that first amount. This is the second amount. Why did this fail? Execution reverted. Okay. Let's take a look at this. Okay, so this requirement should have been fine. That's definitely less than 0.001 ETH. Why is it that this wasn't working? State. Maybe if we take a look at that. No. Overview. Top level call succeeded or failed. Alright. I have to do old school and try to console log at each step because I don't know what's happening. I didn't get an out of gas fee. I think it reverted. Execution reverted. Okay. So what could have reverted? I didn't get this message. Let's see if I did. Oh. Hmm. Just fallback contract. We have this address. Okay, let's take a step back and just work from one step at a time. So this is a contract. We're calling the contribute function. It's picking that up. We send a value of what we passed through. Hmm. Value transfer did not complete. So I think the issue right now is trying to figure out where in the stack did it revert. Um, it looks like that first call. No, no. Hmm. The first call reverted. All right, so I don't know why that first call did not work. So when I initially sent hmm, okay. Why is this failing? Mount one. Should I send more ETH? I don't think that's it. ETH. Okay. Let me see if I can read into this a little bit more. Because the issue is trying to figure out why this call failed. C2. We have hack. And I'm thinking this may give me some more information. I don't know. We'll test it out. Attack flow, attacker contract, attack, that's fine. Value. Yep, that should be right. Yeah, so it needs to be payable. We're good. Oh, this is a payable address. Okay, so we have that. We know this is good. Um, this returns nothing. All right, so here's what we're gonna do. Let's go ahead and take all this out. We need to see if we're even able to contribute this first amount, and then go from there. Also, I'm contemplating whether I should do it, but Hardhat has a feature where you can console log from a Solidity contract, and I'm thinking about just console logging what's going on. But let's just take a step back and try to run this exploit with just this contribute function. All right, so let's test that out. No. Uh, I'm still get this error. Attack receipt is not defined. Oh. Get it outside of here. Okay. Okay. Fusions. Okay. All right, so we got a receipt. Okay, so let's see. It looks like the contribute function is working. Let's come back to my address. Perfect. So it looks like that transaction ran. So, okay, so for anyone who forgot another thing I forgot to mention is anyone who's just learning, if later down in the call stack, if your transaction, let's say, so if we go back to this contract, let's say one of these, remember I have three things that's happening. I have three contract calls. Let's say the last one fails. It's going to show all of these failing. It's going to revert. It's just going to revert this transaction, and all of these are going to just fail. So when testing, you kind of have to, I'm going to just do this where I'm going to test this first, then I'm going to test this next and see where my attacker contract is failing. Obviously, this should be done locally so that I'm not wasting, ETH if I were to actually like pull off a hack. But this is the way. So we see that that transaction works. We have successfully made a transfer of this amount of ETH. So we've contributed. We're now a contributor. Now let's see if this is the one that's causing us issues. I think I have a feeling that the reason this isn't taking any money is because I myself don't have a fallback function, which is ironic. I'm suspecting that what's happening is when I go to withdraw this ETH, I don't even have anything in here that specifies that we could take ETH. So I honestly think that's what it is, which is funny because what we're exploiting is the fallback function. Um, so let's give this a shot. Come on. So it created the contract. That's what we just see just now. It deployed the contract. Now we're waiting for our transactions to run. Yes. Okay. I think that's the issue. So we were able to. Perfect. 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 Let's refresh this. Which, hold up. Okay, yeah, this is the receipt. So that transaction worked. So we created a contract. There we go. I was wondering where this function was. So we create the contract. Let's look at that transaction. It does the two transfers. And now we just want to withdraw. And I need to perform this hack because I'm tired of losing my ETH. I keep losing Ethereum as I do this. So I need to make sure I'm able to complete this hack before we close out, so that I can get all my ETH back. Okay, so let's do this. Uh, so yeah, all we gotta do is just add this. This right here, without all this crap. This basically just says, hey, if someone wants to send your contract some ETH, then let's send it. And let's verify that. Let's ask chat. Let's see ETH. How to enable a smart contract to receive. What's going on, chat? Yep. Yeah. Yep. Good stuff. Thanks. I remember to be nice so that when they take over, they know I'm a real one. All right, so let's go. Let's go ahead and try this withdraw function. So now when I enable this withdraw, my contract is going to be sent some ETH and it's going to hit this receive function because now I've allowed my contract to be payable. So let's try this hack from scratch. And you know what I want to do? I want to go ahead and test some things. So first, actually, all I want to do is check if the balance is 0. And then we can get attacker contract. So the new owner, let me go back. So we're going to expect the new owner I really don't feel like writing. I feel like doing this one. I think honestly, it's just test and see if we would draw the money. That's really like if you know the hack work. This balance of and I don't have a balance set, so let's get that. Let's get this balance. And then after this attack is performed, let's say we want to get the fallback contract. Address or name. Yeah. Okay. So we're getting the balance of this contract address. And let's just check. I can't remember if I have to convert anything to string. Let's look at our old test to see what happens when we grab the balance. Get balance, no. Okay. So if this test runs and the balance is 0, we know that we successfully performed this hack. So let's give it a shot. Okay, looking good. It deployed. This is our deployed contract. Next transaction is perform exploits. All right. And it looks like we've got ourselves a hack. Yes. The balance definitely checked that this was 0, so we are good. Let us validate on testnet so we can actually see this, like see the proof. So we just called this. This is the transaction hash. Yep, deposited. And so you can literally see the transaction flow. So we created, so this is the transaction. We created a contract, right? Create the contract. The contract we create is going to be this OX08. When we look at the attack, OX08, our contract, our attack contract, sends ETH. Then we do something to where now we successfully hacked it. So the contract we were sending ETH to is now sending our withdrawal money back. So we know that this hack was successful. So we want to do another validation. Let's look here. The balance is 0. So we performed an exploit. And instead of doing it with an externally owned account, we did it all with an attack contract, all in one single transaction. So yesterday we went over externally owned account attack, and you see we had to do a lot of steps here to get this attack set up. But here, all we had to do was call this one attack function. So kind of cleaned it up from yesterday to today's. So another validation is this. I guess we really can't validate until Ethernaut says we passed, but I'm pretty confident that we're good. So let's submit. What? What did I do? Oh, I know. So basically, oh man, I hate this. So basically, I claim ownership. So it's doing a check to make sure I am now the new owner. Um, so I have to pass on that ownership somehow. So we're not done. Thought we were done. Feel like I haven't beat the level yet. That was the huge psych. All right, now, so we've successfully drained the balance. Um, Now we just have to claim this ownership, and I'm blanking on passing that ownership over. Let's look back at this fallback. Okay, let's look this up. And honestly, I think that one is supposed to be done with a transaction or not a tech contract, but let's see. Mm-mm. This is the owner. All right, I think I honestly just from not following the instructions of this Ethernaut challenge, it may have ownership contract. So I have ownership, but my contract is what has that ownership. So what if I destroy my contract? What happens? It's actually a good thing to learn about Ethereum. I don't know what happened. Um, hmm. Transfer ownership. No. No, no, no. That's not what I'm trying to do. So, yeah, I think it's really just right now my contract is the owner, is the new owner. And when the Ethernaut, like the Ethernot's validation for this test is to say, hey, um is the player, which is um wait player dot address. Okay. Yeah. So basically the owner, let's see if I can actually look that up. All right, so contract owner. Who's the owner? Transfer this stop balance. Yep. I don't know which address that is. Let's check it out. Mm-mm-mm. Why did it request a new instance? Wow, this is crazy. All right, so let's try this again. And I think I know what happened. Easy mistake. Yeah. I'm gonna explain it, but let me go and do this attack again. So I don't think it is checking that. I think it is checking that the owner changed. Um, but this should work. But we'll see. Ooh, yeah. All right. Now let's do this. Contract owner. Ah. All right. So if you notice, this owner changed to 7.2, and this should be my newly deployed contract. Yep. So I deployed this, it was created, and then it performed the attack. All right, now let's submit. Submit instance. All right, this better work. And if not, then it may just be that the ownership is like, it wants my player address to be the owner. But for certain, we know that this, yeah. So basically, oops, looks like you haven't cracked this level just yet. So what's happening here is, so we know my contract is the new owner, but the issue that's happening here is, I didn't do this via, I didn't do this via my MetaMask wallet. I'm doing this with an attack contract. So that's the issue here. I'm 100% certain. And if you want to see this being passed, we can run the test from yesterday. which is basically this is basically us doing it directly from our wallet. So if we want to change this, and I'm literally wasting ETH doing this, but actually I'm not gonna do that. You see it here. Well done. This is the one we did yesterday. But what's happening is my wallet is completely different. So I actually want to do a test of what happens if I self-destruct. What will that do? I guess that would kind of block the contract. Yeah, let's try to do that. Let's make a self-destruct. Let's just learn. And after this, I think we'll be good for today. Self-destruct. Interest this. Hmm. Yeah. So let's try it. Let's just self-destruct. We're gonna learn. This is actually gonna be a problem later on. That self-destruct can be used for with certain attacks, which is cool. So let's just test it and see how this works. Because I'm curious, if I self-destruct and I'm the owner, what happens to the ownership? Is that just locked forever? Um, and that's a new type of, not new, but that could be a potential attack vector whenever auditing contracts is, if you figure out how to become the owner, and then you just self-destruct, then you can pretty much block any new um, person from becoming the owner of the contract. Right now, you'll see in a lot of reports, people just send it to make the new owner the zero address, and you can't do anything from there. So let's see what happens. Let's add that to attack. So we're going to self-destruct, and the recipient is going to be the sender. Or it'd be owner. What's going on? Oh. Self-destruct has been deprecated. The underlying opcode will eventually undergo breaking changes. Interesting. I didn't know that. Huh. That's cool. Learn something new. So that's being deprecated, but we may still be able to use it. Yeah. We should still be able to use it. So let's try it. Let's here. This is a new contract. And this is good anyways, because it's basically going to send all those funds back to me. All the funds that I had used to hack that contract. Okay. First transaction down, we're good. Let's see if the self-destruct works. And what happens. Nice. Alright, I'm actually pretty excited. Transaction hash. I'm pretty excited to see what this looks like. This is something new that I haven't explored. Alright, so we self-destructed. Hey, wait a minute. Alright, so self-destructed, send everything back over. Now let's go look at the state of this contract. Oh no, this contract. So just this must be the mapping. All that. This is the mapping, and that's the owner. This is the mapping. This is the owner. Interesting. Now let's look at who the owner is. Now that we've called self-destruct. But will it always stay? Yeah, even though this contract doesn't exist. That's cool. So this is the contract that we took over with. And then I self-destructed this contract. So now the owner is like stuck forever. There's no way to there will be no way to. I mean, obviously we can become the owner again by the exploit, but if this contract was programmed in a way where the previous owner can set the next owner, and that happened, then you essentially have blocked the contract from a new owner, and it will be unusable. So that's an interesting attack vector that I'm gonna start using in any reports. That doesn't change like the previous. That doesn't allow the modify. Like basically, if the previous owner has to be the one to set the new owner or admin, that's an issue. Usually, you can just say like, if you set it to the wrong owner, you lose the ability to be the admin, or if you set it to the 0 address, you lose the ability to be an admin. But don't let it be set to a contract that could be self-destructed. So pretty cool. That was a good study sesh. I learned a good bit. Learned a little bit more about making attack contracts and making sure that, at least from Ethernaut standpoint, make sure you follow instructions to be able to claim ownership of the contract, because this wants to make sure that the player is the new owner, and my contract became the new owner. So, but we beat the level because we were able to reduce its balance and hack it. And essentially, we became the new owner because our contract was the new owner. So let's go ahead and come back. I don't think I'm gonna start the next challenge yet. I might end the stream and yeah, I might end stream and go to the next level tomorrow. But if anyone's still on, any questions? Any questions on what we covered? Learned anything? I can't tell if anyone's still on. But if you do, feel free to send me a DM if you have any questions on what we covered today. What's going on here? There you go. Take a look at this next challenge. Hmm. Cool. All right. So I'm looking forward to get to these next challenges, but today we'll go ahead and close out. Thanks, y'all. Let me know if y'all need anything.